Ashley Hawkins, for the record, is messing with me. Okay. Oh, yeah, it's going? Oh, okay. Nice. Okay, so let's see how you guys are doing with these. The first one, derivative of 7. Do we all get 0? Yeah. Now, for the second one, negative 1 over x squared is right. I'm just wondering, did anyone use the quotient rule for that? No, it's kind of like a waste of a beautiful rule, but you could, right? But if you just rewrite this as, how did you do it then? What rule did you use? Power rule. So you wrote it as x to negative 1, so the derivative was negative x to negative 2, or negative 1 over x squared. Nice. All right, moving on. Next one. Whoa. Yeah, so you have, so it turns out to be, that's right, guys? 2 over the cube root of x squared minus 1. As long as it's not in the numerator. Did you put it up in the numerator with, like, of the first fraction? Oh, yeah, that would be wrong. Yeah, I did. Yeah. Yeah, it was just left. So now the next one is a product. So now he has it backwards. It doesn't matter because it's addition. But the first is 2x minus 1 times the derivative of the second. You should have 1/4 x to the negative 3/4 minus 3. Right? So you probably have this first. So you have the 2x minus 1 times 1/4 x to negative 3/4 minus 3 plus the second, that's this one here, times the derivative of the first is just 2. Yeah, I'm going to just leave that. But I'm just going to have it here. So if you did it in the opposite order, I mean, the order, it doesn't matter again, but you would have this answer. Now, I just left it with the negative exponents. I was a little lazy. I know. It's ridiculous. What do you want to do? But it's a little touchy-touch. And then for the last one, I just want to see if you know the quotient rule. So it's a little loady high. So loady high, let's hidey low. How do we do with that one? Little Drake. Draking it up. Yeah. Everyone get the basic rules down? All right. So what I want to do today is I want to make sure, I think there were like 1 or 2 things at the very end of yesterday we didn't get to. Like we didn't get to the chart problems or the second derivative. It takes 2 seconds. It's the easiest. But I got to make sure I just tell you about that. Now you'll never forgive me. We didn't do this. The second, we did. Horizontal tangent, right? Oh, but did we do the chart? You guys, that was great. Oh, so then we have like the easiest thing. Yeah, let's do this. Oh, that's why, and I gave you up to 40, so you had 1 second derivative in there. That was a little tough. Okay. Well, the thing is, you can take the derivative of the derivative, and it's called the second derivative. And the way you write that, if you call your first derivative y prime, the second derivative you can call y double prime. If you call your first derivative f prime of x, the derivative of that is f double prime of x. The third type of notation is a little weird, and I just want to show you where it comes from so it doesn't bug you all year. That's another notation for the second derivative. And this is where it comes from. When you take the derivative of the first derivative, it looks like that. This is saying take the derivative of the first derivative. Now, mathematicians are kind of lazy. They have a lot of other work to do. So they don't want to have to write this all the time. So what do you see when you just look at the numerator? You see like the d, dy? So that's why they call this d squared y. This is what it looks like. And then the denominator, you see dx, dx. They didn't even put parentheses around it. Yeah, but it's like, dx is being squared, but they don't even put parentheses around it, so they write it like that. That's where this notation comes from. Oh, I don't want to use the quotes because that looks like the double prime. So when you're talking about the second derivative, the derivative of the derivative, you might see y double prime, f double prime of x, or d squared y over dx squared. Just realize it just means the derivative of the derivative. And so let's just do one to make sure you're okay with it. So if I call my function f of x, got it right here, what would the first derivative be called? Yeah, we could probably use f prime of x. And what would that equal? 8x squared. I'm glad you didn't forget the squared, because a lot of times people remember to multiply and then they forget about the exponent. Minus 10x. Got it? Okay. Does everyone agree that that would be the first derivative? Okay. Then the second derivative will just be the derivative of that. So f double prime of x equals 16x minus 10, and that's it. Like these. Now, you know the first derivative tells you what the slope of the tangent is. The second derivative you're going to learn later on tells you about the concavity of a graph. But for now, you don't know how to get it. Concave up, concave down. So that. Yep. Oh, that's the next unit. The whole velocity, motion, acceleration. Okay, they're looking forward. So we filled in this part. We just didn't fill in. I think I rushed through this. I think I did. Did we do the first and second one or not? Okay. So yeah, you had for the chart, you just find the derivative, and then you substitute values. You plug in values from the chart that they give you. So then you just plug in values from the chart. But I know I didn't do this one. So let's just finish that up. The second derivative is the blank of the first derivative. Yeah, that's the answer for everything in here. The answer to every question. And the notation, without looking, can you remember some of the notation for the second derivative that we use? Sorry, Jess. F double prime x. Another one. That's the one I want to see if you remember. So d squared y goes in the numerator. Dx squared in the denominator. And then the y double prime. Those are all different ways we can refer to the second derivative. Like d squared y over dx squared, that always bugs the kids. All right, so back to today, back to our J18. I can check any of the homework problems that you want to go over. Right here. So finish 18. It was tough, but it was fun tough, the homework. Yes. 40. Let's go to 40. Was 40 fun? It was good. Fun tough. Stop talking fun tough. Yeah, I'm going to just rewrite it because I can't see this. I tried to. Oh, okay. I'm just going to copy it over. Yeah. You guys can read it to me. I'm just going to make a new one. Okay, so what was the function? 40? Plus 7. Okay, and the first part we had to write the equation of line that was parallel to some line. Okay, and what line did it have to be parallel to? Okay, so parallel to y equals 2x plus 4. So we're trying to write the equation of the tangent line that would be parallel to this line. Okay, so what's true about parallel lines? Same slope. And can you tell me what the slope of this line would be? The slope of this line is 2. How do I get the slope of the tangent line? The derivative. So if we want it to be parallel to this line, we want the derivative, the slope of the tangent line, to equal the slope of this given line. And what is the derivative? 2x minus 6. So when we add 6 to both sides and we divide by 2, what do we get? 4, right? Now, to write the equation of the tangent line, I need to know the x and y coordinate of a point on the tangent line. I've got the x, and I need to know the slope. So, to write the equation of the tangent line, it's going to be y minus, how am I going to get y1? To the original, that 4 that we found, we already got the x is 4, plug it into the original, so we got to get what f of 4 is. We'll figure out that in a second. And then, what's the slope of the tangent line going to be? Oh yeah, it has to be 2. We already figured it out. So it is f prime of 4, but we already know that's 2. And then what goes in the parentheses? X minus 4. So f of 4, if you plug 4 in here, negative 1, because you have 16 minus 24 is negative 8 plus 7 is negative 1. So we have y minus negative 1, so plus 1, 2 times x minus 4. Okay. And the second part, we want to write the equation of a line that's perpendicular to some line. So we're going to want the slope to be the negative reciprocal. We want our derivative to be the negative reciprocal of the other one. So, I'll send it. So for the second part, what's the line we want it perpendicular to? Y minus 1? Y equals 2x plus 4. Okay. So we want our line to be perpendicular to that one, and this one again has a slope of 2. We want the slope of the tangent line, the derivative, not to equal 2. We don't want to have the same slope. What do we want it to equal? Negative 1/2. So now we'll once again just have to figure out what x is that makes the derivative equal to negative 1/2. And what was our derivative again? 2x minus 6 equals negative 1/2. So we're going to add 6 to both sides. 6 is the same thing as how many halves? 12 halves. So we have 2x equals 11 halves. And then you can divide each side by 2 or multiply each side by 1/2. And you get x equals 11 over 4, because it would be taken multiplied side by 1/2. Now you'd have to plug the 11/4 into the original function to get your y1. And the derivative, we already know that the derivative there is going to be negative 1/2. So the equation of your line will be y minus whatever f of 11/4 is equals negative 1/2 x. Oh, what do we get? 11/4. So it would be minus 11/4. I don't know what this number is off the top of my head, like plugging that into the original function, but it should have it on there somewhere. Okay. Yeah, I have the answers for you. Just make sure you understand the process. The one that I thought that you guys were going to have a lot of trouble with, 39. Nope, I didn't think that because you didn't have to do it. Yeah. Sorry. I thought you guys wouldn't have trouble with 28 because, you had the big thing was getting the derivative. And, people look at this, they see a quotient, they see a product, and they say, how do you even start getting the derivative? You can't get them separately. And what you have to do when you want to get the derivative of something like this, ask yourself, is the whole thing, is the whole picture a quotient? If you look at all this, is the whole thing a quotient or just the first part? Just the first part, right? Really, if I had to describe the whole expression, it's a product. So you have to use product rule where you have first and the second. It's just that the first is a quotient. So when you go through your whole product rule, first times derivative of the second plus second, that's where the fun begins. When you take derivative of the first, that's when you have to use the quotient rule. So that's what I wanted to make sure. And then after you write that, you had to plug in a negative a half for all the x's. So that's why that one was really kind of rough. And it actually turns out to be 28. You have to check your work if you didn't get that. But that was the tough part. Then you could write the equation of the tangent line once you had that. But that was rough. Wow, right? Anyone actually get that one right? Okay. A couple people. It's so easy to make one little mistake, especially when plugging in the half or the negative a half, whatever it was here. Yeah, negative a half. Other ones you wanted to ask about? Yes. Which one? 36. I'm just going to see which kind that was again. Okay, for 36, I know this is kind of faint here, but this is one of these chart problems. So first you figure out the derivative using the right rule. And the right rule to find the derivative of a quotient is the quotient rule. On this answer key, whenever I write QR, that's quotient rule. Whenever I write PR, it's product rule. So this might be hard for you to see on here, but you want to do low, negative 3g of x, d high. The derivative of the numerator would be f prime of x plus 0, so just f prime of x. So low d high less high, f of x plus 2. D low, the derivative of the denominator would be negative 3 times g prime of x, all over the denominator square. So it's just seeing if you know the quotient rule. Then you go to the chart to pick up all the values and plug them in. You get like the general idea of it. So it's, you use the right rule, get your derivative, then go to the chart to plug in values. Okay? It looks worse than it is. This one was just a mess with the numbers. You want to practice? Let's practice. Now, there's one thing I wanted to mention to you. I have this, these practice sheets here for you. Let me just get out of this. And so we have a little bit of time. You have these problems. There is a typo on number 3, so I just want to show everyone. It says in number 3 on the differentiation practice sheet, it says find dy x. It's supposed to be dy dx. Now, if you look at number 3, because this is something that's going to happen quite a bit. Stupidness. No, it's scary. They ask you to find the derivative of x squared times radical x. Now, if you want to, you can use the product rule on that and clean it up. But whenever you can actually multiply it out first, it won't be a product anymore, right? So you might want to just multiply them, then take the derivative with the power rule. But my question to you is, how do you multiply x squared by the square root of x? What do you do when you multiply? All right, Jillian. Add the exponents. So then the question is, all right, so what's 2 plus a half? 2.5, tell me as an improper fraction. What is that? Ooh, I don't know why this is. So it would be how many halves? 5, because 2 is 4 halves. And when you add 1 half to 4 halves, you have 5 halves. So if you first multiply them, you can use the power rule. Okay? So that's one thing you might, or if you don't want to, you can keep it like that. But, you know, especially the multiple choice, you got to find the answers. So there's one more thing that comes up over and over again on this sheet, and, well, several times, that I want you to be aware of. If you go and you get the derivative, and you don't see your answer in the choices, it might be a situation that where the power is greater than the root. And I gave you an example here. Like, suppose in your denominator, you get an answer of the cube root of x to the 5th. See how the power is greater than the root? They might not have that there as a choice. They might break it down. They could break down the cube root of x to the 5th as the cube root of x cubed times the cube root of x squared. You see that you can do that? anytime that power is squared, you can break it down and say, oh, the cube root of x cubed is just x. So don't get discouraged if you don't see your answer. If you don't see your answer there, see if you could break down the radical. If that power is greater than the root, you can break it down. All right? Does that make sense? Or you need me to clarify that? Like, you got that? Yeah? All right. So do it. I do think you might want to, for good practice, the ones that aren't multiple choice, I think for yourselves you should try to, clean it up, work it out. But do your best. These are all just the basic rules. You got to practice. The only way to learn them. Oh, that's it for today. See ya.